Three different forms of the quadratic function: the intercept form, the vertex form, and the standard form. Today's video is going to help teach you how to interchange in between these three different forms. First method that you might see is that you need to convert from intercept form to standard form. Okay, so let's say you're given the equation y is equal to 3x minus 4 times x minus 1. This is an equation in intercept form, and we want to make it into standard form. Remember, standard form is ax squared plus bx plus c equals y. And so to do this, we're just going to do our full method. So I'm going to start by taking the x minus 4 and times it by the x minus 1. So I'm going to take x times x, gives me x squared. Then I'm going to take x times negative 1, give me a negative x. Negative 4 times x is negative 4x. And negative 4 times a negative 1 is plus 4. Combining like terms, I end up with x squared minus 5x plus 4. Then last step, I'm going to do my distributive property and distribute this a to every term. So it gives me a 3x squared minus a 15x plus a 12. And I have now written my intercept form equation into standard form. Our second method is we're going to convert from vertex form to standard form. All right, let's say we have the equation y equals negative 2 x minus 1 squared plus 5. So this is equation in vertex form, vertex of 1, 5, and we have an a of negative 2. So to write this in standard form, first thing I realize is when I have x minus 1 quantity squared, that means I have x minus 1 times x minus 1. So I'm going to replace this x minus 1 squared with x minus 1 times x minus 1. Then I'm going to kind of do pretty much what I just did in the last example. I'm going to start by doing my full method here. So let me change a color. So I'm going to take x times x. It gives me x squared. And then it gives me a negative x minus x plus 1. And then in my next step, I'm going to combine my like terms. So I have negative 2, and then my like terms end up being x squared minus 2x plus 1. Our next step is to do the distributive property and distribute this negative 2 to every term in the parentheses. So that's a negative 2x squared plus a 4x minus 2. Keep that plus 5. And my last step is I'm going to combine in like terms. So I got negative 2x squared plus a 4x plus 3. And I now have written this vertex form equation into standard form. Step 3, we're going to convert from standard form to intercept form. I'm going to do a couple examples in this form because depending on how challenging the problem is, it might require a little bit more thought and effort to it. So let's look at the first one. We got a 4x squared plus an 8x minus 12. Now, and go from converting from standard form to intercept form. Intercept form has our two factors. So our key with this is we want to just factor the equation. So I'm going to learn how I factor. So first thing I'm going to look at is I have a GCF. So I want to factor out that GCF of 4. And that leaves me with x squared plus a 2x minus 3. Now that I've factored out my GCF of 4, I'm going to look at these parentheses here and see if I can factor this down. So first thing I know is I need the factors of 3 that subtract to equal a positive 2. So the only factors of 3 are 3 and 1. And the only way I can subtract these numbers to get a positive 2 is I take a positive 3 minus 1, and that's going to give me a positive 2. So I'm going to replace this x squared, this 2x term, with a minus x plus a 3x. And then I'm going to factor this using my factoring by grouping. In my first set of parentheses here, if I look at these two terms, my GCF is x, so it leaves me with x minus 1, plus, because I always bring that sign down, and looking at my second two terms, my GCF is 3, so it leaves me with x minus 1. So I have my GCF now is x minus 1, and what's left over is x plus 3. And now I have fully factored this, and it happens to be in intercept form. Second example, it's a little bit harder because I do not have a GCF, but I do have a number in front of my x squared term, so I have an a, because I know in our intercept form, a has to be factored out. We cannot have a number in front of our x terms when it's in this form, because our intercept form is a times x minus p times x minus q, and there's no number in front of those x's. So this what makes this one a little bit more challenging. I'm going to start the same way. I'm going to try factoring it first. Looking at this, I know I multiply my outside numbers together, and that's 6. So I list all the factors of 6. That's 1 times 6 and 2 times 3. And I want to know the ones that add to equal a negative 7. Well, that'd be a negative 1 plus a negative 6, which will give me a negative 7. So I'm going to go here and replace that middle term with my two factors of a negative 6x minus 1x. And then I'm going to look at my first two terms and factor out my GCF there, which is a 2x. Taking out a 2x, that leaves me with an x minus 3. Bringing down my negative sign. This sign always comes straight down, so I'm going to have to factor out a negative. Then I'm going to look at my next two terms, factor out that GCF, where there's nothing in common, so I want to factor out a 1, a negative 1, which gives me an x minus 3. Putting these together, I get the x minus 3 is a common factor, and that leaves me with a 2x minus 1. If you look, this 2x minus 1 is a problem because we cannot have a number in front of that x. Easily solved. All we're going to do is we rewrite this parentheses, and I'm going to factor out whatever that a term is. So I'm going to take 2 out of only this parentheses. So if I take a 2 out, 2x divided by 2 is x. If I divide 1 by 2, that gives me a 1/2. Then I'm just going to rewrite this in my form that constant goes in the front, and then my two factors. So the intercept form of this equation is y equals 2 times x minus 3 times x minus 1/2. All right, let's do one more. That is so annoying. I don't know why it's giving me such a problem. All right. C. In this example, we're given y is equal to 6x squared plus 13x plus 5. And we want to write this in intercept form. So I'm going to start by factoring it. I got my factors of 30 that add to equal 13. So let's see. Multiply these together. So 5 times 6 is factors of 30. That's 1 and 30, 2 and 15. Oh, there we go. 3 and 10. And those are the ones that add to equal 13, because 3 plus 10 gives me 13. So when I rewrite this, I'm going to do y is equal to 6x squared, replacing the 13x with a 3x plus a 10x. Taking the GCF of the first two terms, and I can factor that out. And I see I can factor out a 3x, and that leaves me with a 2x plus 1. Then I want to look for my GCF of these two terms. Again, the plus sign has to come down. 5 is in common, so it leaves over 2x plus 1. Yes, what's in parentheses is the same. So I can rewrite this as y is equal to 3x plus 5 times a 2x plus 1. But again, I have problems. I have a number in front of my x and a number in front of my x here. So I have to factor out a 3 from the first parentheses, which gives me x plus 5 over 3. And then I have to factor out a 2 from my second parentheses, gives me x plus 1/2. I have a 2 and a 3 factored out, so it multiplies together equals 6. X plus 5/3 times x plus 1/2. This is the most complex way that you're going to have to convert from standard form into intercept form. Our last type of conversion a little bit more room. Alright, so our last type of conversion is when we're going to convert from standard form to vertex form. So that's y equals ax squared plus bx plus c to vertex form, which is y equals a parentheses x minus h squared plus k. So the final answer needs to look in this form. The method we're going to use to do this is called complete the square. And again, I'm going to do a couple examples because this one can be a little bit more complex based on the problem. So we'll start with the most simple type. Alright, so we're given y is equal to x squared plus 4x minus 1. And we want to complete the square on this. Step 1 is you're going to group your x squared terms, your x terms together. Any terms that has x, put in parentheses. That's your step 1. Step 2, if there's a number besides 1 in front of the x squared, you factor it out. But in this case, I don't have any number in front of the x squared, so I can skip that step and move on to step 3, which I call it setting up your blanks. So I got x squared plus 4x, and I want to add some number to this. I don't know what that number is yet, so that when I factor this, it becomes something squared. So something times itself. So this factors into a perfect square. But if I set up this equation and I add some number to this inside the parentheses, I therefore have to subtract some number from the equation, because if I add something and subtract something, I have not changed my function at all. So I have to keep it balanced. Anything I add, I have to subtract. And so now this is the blanks. These two steps here are the setting up the blanks. And we have to figure out what goes into the blanks. This bottom blank is what I usually fill in first, because I look at my B term. Whatever this sign is, that sign comes down. Then I take that 4 and I divide it by 2. So whatever the B is, divide it by 2, and that gives you this bottom blank. So 4 divided by 2 is 2. Then I take 2 and I square it, and it goes into this blank. That's the reason why this is always positive, because even this is negative 2. Negative 2 times negative 2 is positive, so it's always going to be a positive term here. So now I've added 4 to the inside of the parentheses. So since I've added 4 to the inside, I need to subtract 4 from the outside. And then all it's left to do is combine my like terms. Negative 1 minus 4 is actually a negative 5 on the outside. And you are done. You have used complete the square to transform the standard form into vertex form. Our next equation is 2x squared plus a 4x plus 3. Start the same way. We're going to use the complete the square to write this in vertex form. So I'm going to group all my x terms together. But this time I have a number in front of my x squared, so I must factor that number out. So I'm going to take the 2 out, and that leaves us with x squared plus 2x. Now that I don't have a number in front of this x squared inside the parentheses, I'm ready to set up my blanks, copying down everything down. So I got x squared plus 2x. I'm going to add something, and then whatever I add, I need to subtract from my equation. And I'm going to do something squared. So I want to set this parentheses so that I have a perfect square. So I have a plus sign. So my plus sign needs to come down. 2 divided by 2 is 1. 1 squared is 1. Now here's where this one's a little bit different. I did not add 1 to this problem, because remember I have this 2 on the outside, so that means I have to distribute this 2 to everything in parentheses. So I've actually added 1 times 2, which is 2 to the problem. So I need to subtract 2. Then combining my like terms, I get a plus 1. So this would be the equation in vertex form. All right, the last one, the most complex way that you might see this is, let's say I have a negative 3x squared plus x minus 5, and you're asked to write this in vertex form. So the steps are the same. I'm going to start by grouping my x squared terms, my x squared term and my x term together. Then I'm going to factor out whatever is in front of the x squared, so it's a negative 3. Now what makes this challenging is this negative 3 does not divide equally into a positive 1. That's okay. You can use fractions. Fractions are our friends. We love them. So if I take this positive 1x and divide it by a negative 3, I get a negative 1/3 x. So that's what's going to be in my parentheses here. And you can check that. Distribute property. If I distribute this, I get negative 3x squared. Negative 3 times a negative 1/3 x gives me a positive x. So it's still balanced. The equation hasn't changed any. Now that I have an x squared term without a number, with only a 1 in front of it, I can set up my blanks. I'm going to add something inside. That means I need to subtract something on the outside. And I'm going to make this bottom so it's something completely squared. So our procedure again is we take this b term, negative 1/3, and divide that by 2. So that gives me a negative 1/6. 1/3 divided by 2 is 1/6. Now I take this negative 1/6 and I square it. That gives me a positive 1/36, because I square the top number and square the bottom number. Then a positive 1/36 times a negative 3 gives us a negative 1/12. Now, since I am actually subtracting 1/12 from this problem, I now have to change this to a plus sign. A minus and negative equals a plus sign, because this is actually subtracting, not plus, like I had been doing in these other problems. So now, let me give myself a little room over here. We have y is equal to -3 x minus 1/6 squared. And I need to combine these two terms. So to combine these, I need a common denominator. So I can rewrite -5 as 60/12 plus a 1/12. And so that's going to give me -3 parentheses x minus 1/6 squared minus 59/12. And now I've rewritten this standard form equation into vertex form. I hope this helps you when you're converting in between the three different forms of the quadratic equation.